Hi, Andy Piper. Welcome to JAX London.
Thank you very much.
Thank you very much for joining us too. So you're here on behalf of Pivotal to
Yes,
speak
indeed.
about Cloud Foundry. And one of the big things about Cloud Foundry is you're pushing the openness. In fact, it's an open source project. Could you tell us a bit why that's so important for a platform as a service?
Sure. So I think the important part here is overall is lock-in, right? So open source is good because it prevents any one vendor from locking customers into one technology. But I think the analogy that I tend to use when I talk about Cloud Foundry is to look at another open source project. So if we rewind almost exactly 21 years, in fact 22 years, and go back to 1991, a gentleman at the time, Linus Torvalds, sent this little email out saying, hey, I've got this project. It's probably never going to be very big or professional, but it was Linux, right? And so fast forward 21 years, Linux has grown up as an adult. Most countries it's allowed to drink and smoke and all those other things, right? But it's survived, and not only that, it's everywhere. It's in places we don't recognise it or wouldn't expect it. It's in airline entertainment systems, it's in our home routers, it's in our laptops, it's in our phones, in Android and so on. Why is that important? Well, because it was open source, it could continue to adapt to changing hardware and platforms and needs. So it's gone from the server to the desktop to the phone. And it could be bent and changed to adapt to exactly the space that it needed to fit. So inside a router where there's no heads-up display and GUI and all that kind of thing. The same applies to cloud. We're at the beginning of cloud, and we're at the beginning of cloud both in the infrastructure as a service layer, although Amazon Web Service started a number of years ago now. OpenStack's much newer as a project. And we don't know what will come next. Okay, so the fact that all of those things are true means that we want an open platform that can sit on top of any infrastructure. And in fact, Cloud Foundry can run on any infrastructure. It can run on top of OpenStack, it can run on top of EC2, it can run on top of vSphere, and we would like it to be able to run on top of other platforms in the future, other infrastructure platforms. Because that infrastructure layer is essentially just the new hardware. It's the server or the mobile phone or the tablet of the future, right? It's just where our code runs. It's also extensible from languages, right? So we can plug in different languages as well. And again, I come back to the same underlying point that we don't know what will come next. We don't know when Google or Amazon or whoever else will invent the next cool language, or somebody not even on the radar yet, that everybody suddenly starts using.
Now, going back to language support, I understand that Cloud Foundry supports a range of languages, but you're here to talk particularly about how it supports Java and other JVM languages. What makes Cloud Foundry so strong in that regard?
Yeah, so again, good question. So we can support any language that we can create what we call a build pack for. And we borrowed that build pack technology from another platform as a service vendor, Heroku, who open sourced their build pack specification. So we can run, your traditional LAMP stack with PHP, we can run Ruby and Python and Node and so on. But yeah, our Java support is particularly strong. And part of the reason for that is that Pivotal sponsors a number of projects. It sponsors Cloud Foundry, Rabbit MQ, Redis, but it also sponsors Spring. And Spring is the most widely used Java framework in the world.
Of course.
We also have, first-class support for another JVM language, Groovy, which is derived from Java, but is very popular in its own right and runs on the JVM. And really, this explosion of other languages, such as Scala, that have come along and run on top of the JVM and take advantage of everything the JVM gives them, is one of the reasons why the JVM has kind of had its second coming. It's had this kind of renaissance of interest. It's just another load of middleware or hardware that we want our code to run on. So what we do with our Java build pack is we try to make it as easy as possible for you to deploy your Java app, whether it needs just core basic Java or Spring or Grails or Groovy or even in the future JEE. In particular, when I talk about JEE, we actually partner with IBM. They're part of the project, the Cloud Foundry project. They've taken the Java build pack and they've said, well, you know what? We've got this big WebSphere customer base and we'd like them to be able to run their WebSphere apps on Cloud Foundry. So they've added the ability that when you deploy a WebSphere app to Cloud Foundry, it will automatically install the WebSphere application server and configure it. In the same way that we'll install the Spring libraries, if we see that you've got a New Relic monitoring or a database attached, we will install the relevant agents. We're trying to make it as simple as possible, single click or single push to get your application deployed and running.
So that's your day job.
Yes.
but by night you work, you help out with the Eclipse PAHO project.
Yes.
Which is developing the MQTT protocol,
Yes.
Which I now understand is now being pushed for M2M and Internet of Things devices.
Yep.
What makes MQTT so ideal for these devices?
So MQTT started quite a long time ago, in 1999. It was co-invented by IBM and another company, and it was targeted at a space which is quite different to what we see on our networks today. Today we see 4G mobile networks and high-speed broadband and fibre connections, and that's all fantastic, but we also still continue to have very low bandwidth connections, poor mobile reception in places. If you rewind to 1999, we had satellite links, we had dial-up with very low baud connections and so on, and we were dealing with low bandwidth, extremely high costs, so you needed to keep your packet size down, very long latency, and missed packets and dropped packets. So we needed to adapt for all of those things. So MQTT has a number of qualities of service which try to deal with all of those things, but because it's very small and simple, it scales up very easily as well to bigger systems and faster networks. So we've deliberately kept it simple. So we believe it is ideally suited to machine-to-machine and Internet of Things. It's not the same as HTTP. HTTP is a request-response protocol, and it's text-based. So you're asking a question by sending a load of JSON in a big blob of text, and then you're getting a response back. And in order to talk to many endpoints, you're having to make lots of those calls. MQTT is broadcast, and it just sends information it needs over a push. It doesn't ask that request response. So it is extremely well suited to these much smaller devices and smaller environments as well.
And finally, what's the coolest use of MQTT you've come across?
Yeah, so lots of cool uses now. Lots of people are using it. Tend to get involved with it because they start to kind of do home automation with Arduino and Raspberry Pi, because it gives you those hardware building blocks. And there's a project now called Node-RED, which is a Node.js app that runs in the browser that lets you wire together kind of your LEDs and your Raspberry Pis and the events. Maybe it's a tweet or something else occurring, somebody ringing the doorbell, and you wire it together, and it's using MQTT between the components. That's pretty cool. But if you look at the wider world, there's both some cool and some useful uses. One of those is the Isle of Wight ferries that use MQTT as an underlying messaging protocol, and as they approach port, they pass through geographic geofences. So the system scrapes their GPS coordinates as they pass through the geofences and then tweets that they're coming into port. So it's obvious to passengers. However, the coolest use was actually something that happened a number of years ago when I was still at IBM, and that was when the BBC Bang Goes the Theory programme decided to see if they could use the mind-reading headsets that were just emerging for gaming to drive 2 London taxis, and because they didn't actually want to put physical people in the taxis and drive them down the track and accidentally crash, they had these 2 guys sit in behind 2 screens with these headsets on, and then we built my colleagues in IBM built some servos that would actually drive the taxis as these guys were thinking, and that was just cool and fun and hilarious, and it had no practical use at all, but it was really, really neat and cool.
Sounds great. Well, thank you very much for speaking to us, and looking forward to seeing your talks.
Thanks.